Okay, today's lesson is 6.4 rational exponents. So another way that we can write a radical expression is to use a rational exponent. So the square root of 25 is the same exact thing as 25 to the 1/2 power. So they both would give you a value of 5. Okay, the cube root of 27 is the same thing as 27 to the 1/3 power. They both would give you a value of 3. The 4th root of 16, same thing as taking 16 to the 1/4 power, and it would give you a value of 2. Okay, you can check these in your calculator. So if you are using those fraction exponents and you're taking 16 with your caret button to the 1/2 power, you will need to use parentheses, otherwise it will not do it properly or do it the way that it should calculate it. Or if you can change it to a decimal, you could say 16 to the 0.25 power, but you couldn't do that with your 1/3 power. So up to you how you want to kind of check that work. But by definition here, if the nth root of a real number and m is an integer, then so any base to the 1 over n power, so your same base is what's going to be inside that radical, and then whatever your denominator is going to be your index. Okay, with all the examples in that table, all of them have 1 as the numerator. You could have another number on top there that isn't 1. That just means that that is your exponent that you are raising it to, and then your denominator is still going to be your index. And you could write it in either way. You could think of it as I am raising a to that power of m, and then I'm taking the root, or I'm taking the root of a, and then I'm raising it to that power of m. Okay, all of these would be I'm taking the 4th root, raising it to the power of 1, but to the power of 1 isn't going to change anything. I'm taking the cube root, raising it to the power of 1, taking the square root, raising it to the power of 1. Okay? So n is your index, m is the power. All right, so if we go to simplify these next few problems here, you are allowed to multiply numbers together that have the same root or power. So a few different ways you can think of this. You can look at, well, they're both the 1/3 power. So I can take 10 times 100 and get 1,000 to the 1/3, but I do not change the 1/3 power. Okay? Or you could think of this as the cube root of 10 times the cube root of 100. Then since they're both a cube root, I am allowed to multiply what's inside, which gives me the cube root of 1,000. So either way, 1,000 to the 1/3 power, we know is the same value as the cube root of 1,000, whether you'd rather convert it to that radical form, if that's helpful or not. But either way, we get a value of 10. Very similar with letter B here. 2 is being raised to the 1/2 power. 8 is also being raised to the 1/2 power. So they have the same exponent. You're welcome to multiply them together, but keep that same exponent. Sometimes I have students that try to add the exponents together and multiply them together. You're doing too many things that you're not allowed to do. So if that's going to be a problem, then I would say you should be somebody who should change it to its radical form so that you don't accidentally do things with the exponents you should not be doing. Okay, there's no exponents now when I change it to this radical form, and I just know that means to multiply those together to one radical, and now I get 4. Okay, whether you change it to this form and then you tell me that's 4, that's fine. It's up to you. I just know I've seen students do things with the exponents they shouldn't be doing. So if you do have that problem, then just always change it to radical, and you should be okay. All right, you will be asked just to write the following expressions in radical form. So you're just changing it to its other form and practicing it in both ways and knowing that it means the same thing. So with C, there's not going to be any work with a problem like letter C here. So be very careful about that 2. Okay, the 2 is not being raised to the 3/5 power. If it was, we would see parentheses. Now it's being raised to the 3/5 power. That one is not. It would be to the first power, that little invisible 1 we got there. So 2 has nothing to do with the radical. It will be on the outside. X is being raised to the 3/5 power. So X is going to be in the radical. Okay? 5 is my denominator that tells me the index. 3 is the numerator that tells me the power I'm raising x to. And that is my answer. Okay. Letter D here. So one more thing we'll have to do with this one. We have a negative power, so we will still need to use positive exponents. So I'm going to rewrite this with positive exponents. So I use my reciprocal, and I put 5/2 as a positive exponent. Now be really careful, because now I'll start to see students who will want to flip that to 2/5. So like, oh, I need to do the reciprocal. We did the reciprocal of 1/y. We have never flipped over the exponents, right? If I give you y to the -2nd, you do 1/y squared. You don't all of a sudden turn that into 1/y to the 1/2 power. We've never done that. So don't recreate and make new stuff up, okay? So I've got 1/y to the 5/2. Now I'll go ahead and change this to its radical form. So my denominator is a 2. So that means I'll do a square root. And this would be the 5th power. Okay. Now I have seen when we're working in the book, sometimes the book will leave this as an answer. So Math Excel might accept this. But then sometimes not, because we technically haven't rationalized the denominator. So I don't like when they do let you leave it like that. So we're going to go over rationalizing, and I know it will accept it as a rationalized answer as well. Okay, so I don't want the radical in the bottom. I want to get a perfect square. I don't need to take it y to the 5th times y to the 5th, because that's going to give me y to the 10th, which is a perfect square. But y to the 5th can be simplified further, so I don't want to have to simplify the numerator and the denominator. I only need to multiply it by the square root of y, because when I add those exponents together, when I go to multiply those denominators, I will get y to the 6th, which is an even number that I will be able to take the square root of. Okay, so I'll do that to the top and bottom. So on top, I get the square root of y over the square root of y to the 6th. The square root of y to the 6th would be y to the 3rd, and then I've got the square root of y. To me, that's the true correct answer, but Math Excel might let you get away with this. You can try it out. If it says it's in the wrong form, then rationalize it. Okay. All right, these next two, I'm going to have you go and put they're in radical form, and we're going to put them in exponential form. So I should notice this is a square root. So I've got my 6. It would be raised to the 1st power, but it's in the square root. So that would be 6 is to the 1/2 power. X is being raised to the 7th, but it's in this under the square root. So that would be the 7/2 power. That is it. That is my answer. There is no work that you need to show. It is just you have the knowledge of what number goes on top and what number goes on bottom for each of the rational exponents. Okay. For F, slightly different. So since there are parentheses here, that means both the 3 and the x are being raised to the 9th power. Okay, on the left side here with E, just the x was being raised to that 7th power. Okay, and then they are both under a square root, so they will need a denominator of 2. You could also write it as 3x in parentheses to the 9/2, since they are both being raised to the same power. Both are fine. Okay, we'll continue simplifying a few more here. So we were dealing with some variables here, not much more we can do with simplifying any further, or we're just changing it to different forms. So now we'll deal with and get kind of an actual number value when we're done. So negative 32 to the 3/5. My suggestion would be to change it to its radical form. So the 5 is on the bottom, so that means the 5th root, and negative 32 to the 3rd power. Or another way you can write it is to do the 3rd power after. Okay. So up to you. I'll show you both ways of calculating this. This way is my preference because right now I'm getting out my calculator right now. So if I go this route, I need to take negative 32 to the 3rd power, which I don't know in my head. So I'm taking the 5th root of negative 32,768. Now I will have to have a calculator that can do 5th roots. Okay. So if I'm on my graphing calculator right now, so I'll need to use the math button, and they have a cube root in there, but we want a 5th root, and then they have an x like that. So I'll need to type 5. Then I will type math and negative 32,768, and then I will press enter. And I did something wrong, so I'm going to redo it. All right, then I get negative 8. So my answer is negative 8. That is not the way I like to do it because it took me too long. Okay, I had to do most of it on my calculator. If I go this route and I do the 5th root first, the 5th root of negative 32, I know. Maybe you don't know. Hopefully you know it at this time from doing all the problems you've been working on in this unit. But that gives me negative 2. Negative 2 to the 3rd power is negative 8. I'm done. Okay, I never had to pull out my calculator for that. Okay, also if you do not have a graphing or scientific calculator, you're not going to be able to do a 5th root. Okay, so my suggestion is to do the root first, make a nice small number, and then we're raising it to that power. Okay. All right, we'll take a look at h. Notice with h here we have negative 3.5 as my power, so we haven't seen one with a decimal yet. So if you're given a decimal, you'd have to change that to a fraction. So 7 divided by 2 would give you 3.5. Okay, same thing here. I'm going to do the reciprocal. Now my exponent would be positive. Okay, then I'll go ahead and I'll change it to its radical form to kind of get a better idea of what the value of this is. So then I've got the square root of 4. You can then raise it to the 7th, or the square root of 4 to the 7th power. Once again, your choice. This is the method I like because I'm taking the square root of 4, just 2, and then I'm raising it to the 7th power. So 1 over 128. Okay. Over here, I'm taking 4 to the 7th. So then I got 1 over the square root of 16,384. So then I would take the square root of 16,384 and find out it's 128. Your choice. You do what works for you. I showed you the way I think is more efficient. Rock we won. Okay, last 2 problems we're going to simplify here. I always get questions on these types of problems. Students get very stuck with these and how they simplify them. Okay, with I, notice that I have a square root times a cube root. So I cannot multiply the x and the x squared together. I can't change something from a square root to a cube root. So they get stuck and they don't know what to do. Okay, the only way I can simplify this is if I change it to its exponential form or with rational exponents. Okay, so another reason why we need to be familiar with these to simplify something further. So x would be the 1/2 power times. The next one here would be the 2/3 power. Okay, once I change it to this form, now I've got common bases and I'm multiplying, so I must add those exponents together. Okay, so I'm taking x to the power of 1/2 plus 2/3. Okay, now I need to remember a little bit on how we add fractions, right? We'll need a common denominator. Don't just type this into your calculator and have it do it for you. We'll need some practice with this because we're going to do an entire chapter of fractions and it'll involve variables. You can't just plug it into your calculator mindlessly. Okay, so I'll have to multiply this denominator by 3 and that denominator by 2, so I get a common denominator of 6. I multiply the bottom by 2, I multiply the top by 2. I multiply the bottom by 3, I multiply the top by 3. So this would turn into 3, 6 plus 4, 6 gives me 7, 6. So the answer would be x to the 7/6 power. Okay. With J, very similar situation here. I cannot divide those 6's because they are in different roots. Okay, so the only thing I can do is I can change it 6 to the 1/3 power since I got the cube root on top, and 6 to the 1/4 power since I have the 4th root on the bottom. Now they have the same base, and when I divide, I must subtract those exponents. So I'm taking 1/3 minus 1/4. Once again, I'll need to get a common denominator. So I'll multiply this denominator by 3, that denominator by 4, the right denominator by 3, so I get 12 as the common denominator. Do the same to the top and bottom. So then I get 4 twelfths minus 3 twelfths is 1/12. So 6 to the 1/12 power would be my answer. I mean, if you wanted to write it as the 12th root of 6, both are fine, both are considered simplified, up to you. Okay, that is it for our lesson on rational exponents. Good luck with your homework.